In this section of notes, we're going to be talking about rotations. And all a rotation is, you're just taking a geometric figure and you're turning it about a point. The point of rotation, which is going to be the first blank, what is this writing? The point of rotation, don't know why that's having just a hard time writing, is the fixed point about which the figure is turned. The number of degrees the figure turns is what we call the angle of rotation. You can either rotate a figure clockwise or counterclockwise. The notation for a rotation is just a lowercase r. Right? Then you'll have the angle of rotation and the center of rotation. So you look at this example. We have a lowercase r here. We have the angle of rotation, and then it's what it's being rotated about, and then the figure that you're rotating. So if we look at these diagrams below, it's just a summary for clockwise rotation, counterclockwise rotations, which just means the opposite way of a clock. If you're rotating something clockwise 90 degrees, you have to remember you flip the point. Okay, 90 degrees, you flip the point and make the first new number negative. So here, the point was 2, 3. So we flipped it to make it 3, 2, and then we made the first number negative. So then the new point's negative 3, positive 2. For 180 degrees, so another 90 degrees, the points stay the same, but both points become negative. So the x values become negative and the y. So here, we started with 2, 3. If we go 180 degrees about the origin, then it becomes negative 2, negative 3. For 270, you again flip the points, but this time the x value becomes negative. So if we started out with 2, 3, we flip it to become 3, 2, but the second number becomes negative. And then if you rotate it 360 degrees, then it's back to where it started from, so the numbers stay exactly the same. Any questions over that? Well, we can't really ask questions because it's a video. How to have it. True or false? Rotation is an isometry or rigid motion. The answer is true. Because again, you're not changing the size or the shape. You're just changing the location. Okay? Another option you can do is just turn your paper to see where your new image should be. Count along one axis. Example, up 4, right 3. Then rotate to a new axis where your image will be, and repeat, up 4, right 3. That's another way of looking at it. So we get some practice. We want to graph this triangle. Negative 5, 5. Negative 9, 1. Negative 2, 2. So, and then we want to rotate the triangle counterclockwise 90 degrees. So I like to rewrite my new points. So we have negative 5, 5. We have negative 9, 1. And then we have negative 2, 2. and it's clockwise 90, so remember we're going to flip the point. So our new point's going to be 5, -5, but because it's 90 degrees, the first number becomes negative. So when we flip this one, it becomes, that's supposed to be 1, -9, but then we make our first new number negative. And when we flip this point, it becomes 2, -2, but the first number becomes negative. And then you're just going to plot your new points. -5, -5, -1, -9, and then -2, -2. And there we go. There's a triangle rotated counterclockwise 90 degrees. Okay, so the next one we want to rotate it clockwise around the origin at 180 degrees. Same kind of concept. You're just switching the signs of your x and y values. We're rotating it 90 degrees. Again, we're just going to, why did the eraser pop up? And 180, you just flip the sign. And then 90, you're still going to flip it and make it not the first one negative, but you're making the last one negative. Okay, because if you look back at the previous one, because it's clockwise, so we're starting out with x, y. We'll just use this grid for example. Okay, if we rotate it clockwise, so the way in the clock 90 degrees, we're rotating into this quadrant, but because these are, it's then going to be, because we're in this quadrant, it's going to be like rotating it 270 degrees. So it's going to be equivalent to 270. Okay, if we're starting out in this quadrant and we rotate it 180, it's still ending up in the same quadrant. So it doesn't really change the rule for 180, which is nice, but it changes the rule for 90. So it's kind of backwards. 180 stays the same and 360 stay the same, but for clockwise, 90 and 270 switch. So if it's talking 90 clockwise, it's the same as saying 270 counterclockwise. So you flip it and then you make the x value negative. Okay, so for A, okay, we have our points -5, 5. We have our point -9, 1. And then we have our point -2, 2. Okay, if we flip -5, 5, or because it's 180, we just change the sign, so it becomes 5, -5. The signs flip. 9, -1, the signs flip, and then 2, -2. So we plot those. It's 5, -5, 9, -1, 2, -2. So there's that image flipped around 180 degrees around the origin clockwise. So we went the direction of a clock. Okay? I need to pause it because I'm going to erase A. Don't erase A, keep it in your notes, but I'm limited on room, so I'm going to go ahead and erase it. For B, again, it's 90 around the origin clockwise. So we're starting here, and instead of going counterclockwise into this quadrant, we're going here to this one. So that would be like saying taking this image and going 270 with it going 1, 2, 3 quadrants. So that's why we flipped the point but made the second one negative. So if we start out with negative 5, 5, negative 2, 2, and then negative 9, 1, and flip it, and this time change the second number. So we become 5, 5, negative 5. It's a pen. Oh my gosh. I want the pen, thank you. It would just become 5, 5 because we flipped that and changed the sign. So if we flip this, it becomes 2, positive 2 because we flip it, change the back sign, and then 1, 9. Flip it, change the back sign. So then we're going to replot these new points. So then when we plot it, it's 5, 5, 2, 2, and 1, 9. And there we go. Now it is rotated clockwise 90 degrees. Okay. Some objects have what we call rotational symmetry. This occurs when a figure can be rotated less than 360 about a point so that the pre-image, the original figure, and the image, the transformed figure, are congruent. The order is the number of rotations that occur to create rotational symmetry. Okay. And if we look at this pentagon, it's a regular pentagon because it has all the same sides. And it has rotational symmetry, and the order is 5. Because if we rotate it once, we get a pentagon again because we take this and we rotate it. We got the same pentagon, same. Rotate it again, we'll have the same. Rotate it again, rotate it again, rotate it. It says 1, 2, 3, 4, 5 rotations of rotational symmetry. You notice if you have a regular polygon, however many vertices it's have, that's how many rotational symmetry it has. If we look at a lightning bolt, lightning bolt has none. I can't really rotate the lightning bolt because if you take it and rotate it, you have to go all the way around to your back to having a normal lightning bolt. A heart also does not have any rotational symmetry because no matter how you turn it, you're not going to get another heart. And again, we have another regular polygon. So yes, it has rotational symmetry. And the order, how many vertices it has is 1, 2, 3, 4, 5, 6. So as the order is 6. And there you go. There are your notes.